The resistance of cipher to attack, which is the main object avoids the attack, is the secrecy of the key. Computers are used to guess the key or crack the key very much easily when compared to manual method. In previous or older time, the brute force attack was difficult because of everything was manual. When everything was manual, it was difficult to guess the key. Hello students, welcome to the next session of network security. In this session, I'm going to explain you about different kinds of ciphers. In the last session, I told you about the traditional key ciphers, how they are going to do that, and the types of ciphers like symmetric key ciphers and asymmetric key ciphers. Now comes the categories of symmetric key ciphers. That means symmetric key is only one key will be there that will be communicated between the sender and the receiver. Okay, this is about something about the symmetric key ciphers. Today, in this session, I'm going to explain you about the one of the kind of symmetric key cipher, that is the substitution ciphers. Before studying what are substitution ciphers, there are certain concepts that will be taken from the basics of the cryptography. Okay. The first thing is Kirchhoffs Principle. There will be a principle known as Kirchhoffs Principle, which is named after the scientist Kirchhoff. Okay. What does this principle says is that while developing a network security or cryptographic note or generating a cipher, okay, one should always assume that the adversary or the attacker knows the encryption or decryption algorithm. We have to predict. We don't know whether they know the algorithm or not. We have to predict that the attacker knows the encryption and the decryption algorithm. That means if our opponent knows the method to attack us, if you assume that the opponent will attack us, we'll be cautious and take necessary measures to protect ourselves, is it not? If we feel that nobody is watching us, nobody can do any harm to me, we'll be relaxed and do our normal work. If we assume that there is something dangerous that can happen over us, we'll be cautious and we'll take necessary measures of protecting ourselves. In this principle also, it suggests to the security developers or who generates the ciphers that we have to assume that the adversary knows the algorithm, encryption and decryption algorithm. Okay. The resistance of cipher to attack, which is the main object avoids the attack, is the secrecy of the key. However, how much you increase the secrecy of the key, security of the key, the data will be secured as well. Okay. Security of the key decides the security of the data. Okay. What does the attacker will do? Is he going to get openly the key of a data? Is he'll usually guess the key. This may be the key, that may be the key, because the adversary will know what are the different techniques that can be used to generate a key. What are the different methods the encryption will be done. Okay, adversary will be aware of that. What else he will do is, he will guess the key. But what the security must do is, cryptic techniques must do is, it must make the difficult task of guessing the key. The task of guessing the key must become difficult, that it should not be necessary to hide the algorithms. You should not hide the data. your key must be so much strong that the adversary will not be able to recognize the key. Okay. So, where, for example, if you take the password of an email, if you give only characters or if you give only numbers, the site will, page will suggest you the password strength is very weak. You include the characters, symbols, numbers, everything to make it jumble so that it will be difficult to analyze the password. What does the attacker will do, get into an account is, he'll guess the password. Even though he knows username of your ID, he may not get the password. But how do he cracks your email is by guessing the password. Usually what will be the password is like our birthday or something related to our life. So what does the attacker will do is he will go on guessing what may be the password you have put on to your email account. Is it not? So he'll guess, and sometimes guess will become correct. In such a case, he can crack your email. In the same way, the attacker or the adversary in a network security issue will guess the key of the encrypted code. Okay, your key must be so much jumbled that the attacker must find it difficult to guess the key. Okay. So key domain for modern ciphers are so large that it makes it very difficult for the adversary to find the key. Okay. Key must be so much strong that the adversary will not be able to access the data or access the key or assume the key or guess the key. This method is usually used in military purpose. Okay. If some terrorist or somebody, enemy, if he sends the message to another one, his co-worker or in a group, if the enemies sends the message within themselves, somehow the military persons will get into that message. Okay, what does the militant will do is, they go on guessing the solution for their code. It will be coded message between the enemies. What does the military person must do is, he has to go on guessing what may be the actual message that will be sent between two enemies. Okay, he go on guessing the key word or key mechanism through which the data has been or message has been coded. Okay, it was easier, guessing the key was easier with the traditional methods with the computers. If it is manual, it will be difficult to guess the key. But because of the computers, traditional ciphers has lost the importance because computers are used to guess the key or crack the key very much easily when compared to manual method. Okay, that is why today's modern ciphers will make the key generation or key so much difficult to guess that even the computers will not be able to crack the key. Okay, what are the different methods of ciphering? What are the different methods of generating a key will be the concept we are going to study. Okay, next is crypt analysis. What is this crypt analysis all about is, as we know, cryptography is the science and art of creating the secret codes. Okay, in this, crypt analysis is the science and art of breaking the codes. What does the crypt analysis says is, you must break the code. What are you saying? If we are the ones who generate the key, we must crack the code of others. It is not breaking the code of others, rather it is breaking our key itself or our message itself. Why do you need that? If we are the generators of the key, we have encrypted our data, what the necessity is there to crack the code? You need crypt analysis to check how vulnerable is our crypto system and helps you to create better secret codes. What is the vulnerability of your cryptic code will be checked with the help of crypt analysis. Okay, ourselves will check whether it is working properly or not, whether it is a strong cipher we have generated or whether it is a weak. It is like testing the project. Okay, what is the testing principle is, what does the test will do is, we have to find out the vulnerability or strongness of the pattern. Okay, so why do we do test in a project is to find out the mistakes in our project, because finding of the mistakes by the client will not be a good sign, because it will affect the business of an organization. So finding errors by ourselves in our project will be far better than finding the mistakes by a client or somebody else. In the same way, checking the quality of our cryptic generation, testing of that cryptic generation by ourselves is better than letting attackers to attack our key. Okay, so this is where crypt analysis plays an important role. Crypt analysis is similar to testing phase in a project development. Okay, if we have developed a page, you must put on all the inputs to check how does it is going to work. If you have a text box, you have to check whether it can accept number, character. If it is username or if it is telephone number, text box of a telephone number, you must check for that. If it is the text box is going to accept numbers or only, or it is going to accept the characters also. So that is where, in the same way, crypt analysis checks for vulnerability of the code you have generated. Okay, these are the crypt analysis attacks. Okay, attacks by themselves. We will attack on ourselves to check how much strong I am. Okay, so crypt analysis attack has the type checking the cipher text only, known plain text, chosen plain text, and chosen cipher text. Okay, there are 4 types of attacks that can be done by the developer of the or generator of the code itself, like the cipher text only, known plain text, chosen plain text, and chosen cipher text. How do you check for the vulnerability of a code using these 4 types? We'll be discussing now. Okay, so first one is cipher text only attack. What does the cipher text only attack will suggest is, it assumes that Eve has access. Eve is an attacker or an intruder or an adversary. She has access only to cipher text, not the plain text. She has got the cipher text passing through a network path. Okay. She tries to find out the key. What she will do is, she will try to assume the key. And the plain text, using the key, she will try to generate the plain text by assuming the key. What may be the key? By assuming, she can generate the plain text. Okay. Which assumes that, this attack assumes that she knows the algorithm. If she doesn't know the algorithm, she will not try to crack it, is it not? So we assume that she knows the algorithm. Okay. This is the most probable attack since it requires only cipher text. Okay, only cipher text will be obtained by the Eve, which is sent by the Alice, okay, to the Bob. She is the sender and he is the receiver. Eve is the attacker or adversary. The Eve, through the help of, by breaching the network path, she will get the ciphertext, okay. By analyzing or assuming the key, she will generate the plain text. Now, you have to check by getting the key and transferring it to plain text. Is this possible to assume the key and generate the plain text using the ciphertext? I have to check for that, which is called as the ciphertext only attack. She didn't get the key, she got only the ciphertext. What she has to do is, she has to assume the key, okay. The next thing is, in ciphertext only attack, we have different categories of attack. One is the brute force attack. In this brute force attack, it is also called as the exhaustive key search, okay. In this, Eve uses the set of possible keys. She will use possible keys. This may be the key, this may be the key. She will go on guessing the set of keys, okay. This brute force attack assumes that she knows the algorithm and knows the key domain. What are the possible keys that can be generated over that ciphertext? She knows the key domain. Key domain is set of keys, okay, that can be used to guess a plain text, okay, guess a message, okay. Using this key search method, she will try to decrypt the message until a plain text makes sense. She goes on assuming the keys from the key domain and she tries until she gets a meaningful message from the ciphertext, okay. In previous or older time, the brute force attack was difficult because of everything was manual. When everything was manual, it was difficult to guess the key, okay. What may be the key? This may be the key, that may be the key, like this. But with faster computers, guessing of the key has been taking less time. So because of this, guessing of the key has also become more possible than the manual method, okay. How do you prevent then this brute force attack is, number of possible keys must be very large. You cannot keep some 5 to 10 key domain. You have to have hundreds of possible keys. In that, the adversary must not be able to guess the key. So that is why it is called exhaustive key search. Searching for the key until it gets exhausted, until the domain finishes, or until there is a meaning, sense, or there gets a plain text which having some meaning or some sense. Until then, until it exhausts, you have to search for the key. That is why brute force attack is also called as the exhaustive key search, okay. Next is the statistical attack, okay. Brute force attack, the statistical attack. In statistical attack, it uses some inherent characteristics of a message, okay. It will not go to the case of ciphertext. It will not take care of ciphertext. It concentrates on the plain text. What does this attack will do is, it will use some inherent characters of the plain text language to launch a statistical attack. It will generate the statistics. It will go for assuming something, doing some permutations and combinations, generating some format, report. So like that, there will be statistic-wise analysis to generate a key or to guess a key. Like example, which is the most widely used key or most widely used letter in the ciphertext? Letter E is the most frequently used letter in English text. What does the statistical attack will do is, it will statistically analyze the repetition of the alphabets in the ciphertext. How much time the text has been or the letter has been repeated. If it is repeated for this much time, what may be the letter? So they are going to assume it based on the statistics. Okay. So crypt analyst assumes that the most frequently used character in a ciphertext will be E. So if it is most widely used, then it will definitely be E. He'll assume that based on the repetition of the same letter in the ciphertext. Okay. After finding few pairs, analyst finds the key and decrypts the message. Okay. Based on some patterns, he will guess the key and decrypts the message. Then how do you prevent it? The ciphertext should hide the characteristics of the language. If the message is of different language, he must hide the repeating characters, or he must hide the repeating letters, or he must change or hide the natural characteristics of a language. Like in some language, some letters will be repeated more times. Some alphabets will be repeated more times. So this general characteristic of a language must be hidden from the attacker or the adversary so that he will not be able to guess the repetition of the characters. Okay. We have another pattern attacks. Okay. In this, even if the characteristics of the language is hidden, even though I have hidden the characteristics of the language, there may be patterns in the ciphertext. There will be some patterns like the, so, or that, this. So this may be repeated. So there will be pattern of generating these characters. Okay. The attacker or the adversary will guess the patterns in the ciphertext. This character has been repeated here. That means these two words must be same. What are they? Are they same? If it is so, or if it is that, or if it is money, what it is? He will go on guessing based on the patterns in the message. Okay. Crypt analyst may use pattern attack to break the cipher. Using this pattern, he'll get into your message. Okay, how do you prevent this? Keep the ciphertext as random as possible. Do not repeat the pattern for all the words. If you have used the word the 5 times, if you are going to give same 1 key or 3 key, the will be converted as or encrypted as, if it is key is 3, it will be W, K. So D will be encrypted as WKH with the K3, key value 3. If you have repeated D 5 times, in the message, encrypted message, you will get WKH 5 times. Okay. Now, the crypt analyst will try to assume this word. What will be the word? WKH, repeated 5 times. The. Okay, repeated 5 times. Does it make any sense? Yes, it will make a sense. Then he'll decrypt the message. Then how do you prevent this? Keep the ciphertext random. Sometimes if it is written as WKH, for next T, then make it UIF. Next time to the THE, you generate or you encrypt THE the using UIF with key equals 1. Okay. Or you generate different characters. U, J, G, like this. You randomly change the alphabets that used to encrypt the characters, letters THE. Okay. So this is how you can prevent the pattern attack. Next is the known plain text attack After ciphertext only attack, next comes is the known plain text attack. What is the type of attack is? In this kind, the adversary has access to some plain text or ciphertext. He will get again the ciphertext through the network path, pairs in addition to a newly intercepted ciphertext. She'll get another pair. Sometimes you have sent a message previously or 2 days ago. She has got a pair of plain text as well as the ciphertext. Okay. You will send the same message once again after 2 days. Now she has a set of plain text and ciphertext. She will match the next new ciphertext with the old pair of plain text and ciphertext. This time it will be easier for her to assume the data or predict the message you have sent to the Bob. Alice had sent to the Bob, which is called as known plain text attacks. Plain text is known to me previously. Now I know the plain text that have been sent by you to the receiver. So that is why it is called as the known plain text attack. In this attack, she has access to the previous plain text or ciphertext. She pairs in addition to the newly intercepted ciphertext that she wants to break. The ciphertext she wants to break, she will compare it with the previously plain text and she can get the same message. She can get the message or she assumes the message. How do you avoid this known plain text attack is by not sending the same message on the same network path. Either you can change the message or you can change the network path. In such a way you can hide the message from the adversary. Okay. What is the assumption is that the plain text and ciphertext pair is collected earlier. Somehow she has collected the plain text as well as the ciphertext previously. So she can compare the newly obtained ciphertext with the previous one. So you have to assume that. Example, Alice sent a secret message to Bob, but she made the message public. Somehow the message has been become public, which was collected by the adversary or the Eve. Okay. The newly intercepted ciphertext can be interpreted only if Alice has not changed the key while sending it. Either she has to change the message itself or she has to change the key. If key is same and the ciphertext is also same, the message is also same, then Eve can easily get into the message. She can easily assume what will be the message. Okay. Chances of these kinds of attacks are less. Why it is less is most of the times same message will not be sent twice on the same network path, or the sender usually changes the key to encrypt a message. Okay. Message is usually not public and the key is frequently changed. Each time key will be changed so that assumption of known text attack will be avoided. Okay, because of this, known text attack chances are very much less because of changing of the key frequently. Okay. Next is the chosen plain text attack. In chosen plain text attack, it is similar to the known plain text attack. But the difference here is the plain text or ciphertext pairs are chosen by the attacker. Okay. What will be the pair that I am going to check? It will be chosen by the attacker. That is why it is called as the chosen plain text attack. Here, plain text will be chosen by the attacker. Possible only if Eve has access to Alice's computer. If somehow Eve access to the plain text of stored in the Alice computer, she will have the pair of plain text as well as the cipher text, like in known cipher text attack, she'll get the pair of the plain text as well as the cipher text by breaking into the Alice computer. Now, if when Alice sends the new message over the same path, she can guess the message or she can get into the plain text. Okay. Key is not revealed as it is part of the software. So it will be combined with the message so that key will not be revealed to the attacker or the adversary. It is very easy to implement, but chances are very much less. Okay. We assume that Alice has made necessary security measures so that the adversary will not get into the Alice computer. Okay. In such a case, the chances of chosen plain text attack will be very much less. Another kind of attack is the chosen cipher text attack. Now, this time it is cipher text, not the plain text. And the attack is on the receiver's computer, not on the sender's computer. Okay. Similar to chosen plain text attack, except that this time cipher text is chosen. Who is going to get how she is going to get the cipher text is with the help of receiver's computer, or in this example, Bob's computer. Okay. Eve has somehow gets access to Bob's computer. She'll get into access the Bob's computer and wait until Bob decrypts the cipher text. She'll wait until Bob decrypts the message. Okay. Once he decrypts the message, she will get into that pair of plain text and cipher text, so that next time Alice sent the message with the same key to the Bob, she can predict the message. Okay. Uses the plain text at Bob's end. She'll get into the message pair of cipher text and plain text so that she can predict the message. Okay. Next comes is the categories of traditional ciphers. That is about different kinds of crypt analysis attacks. Now we shall study about the different kinds of ciphers. Okay. There are different categories of traditional ciphers. One is substitution cipher. Okay. Replace a symbol with other symbol. Next we have transpositional ciphers. Reorder the position of the symbols in the plain text. This is replacing, substituting. Another one is transposition, changing the position of the alphabets or symbols in a plain text, which will generate the cipher text. Okay. Now we shall look into the substitution ciphers. Okay. In a substitution cipher, the cipher is going to replace one symbol or substitute one symbol with another symbol. Okay. Example, as I have said in the previous session, if alphabets are there in the message, then replacing A with D, if you have an A in the message, it will be replaced by D. If digits, then replacing 3 with 6. You will substitute another symbol for the current one. Okay. Substitution ciphers can be categorized as either monoalphabetic or polyalphabetic ciphers. Monoalphabetic ciphers and polyalphabetic ciphers. Okay. What are these monoalphabetic and polyalphabetic ciphers? Okay. In monoalphabetic ciphers, a character in plain text is always changed to the same character. Same character is used to replace the character in the plain text. Okay. In the cipher text, regardless of the position, in whatever position it is, same symbol is replacing the characters. Okay. Example, if algorithm changes A to D, then this is done for all the occurrence of A. If you have used the word analysis, if I am going to replace A with D, I am going to do D replacing all the A's. Same character will replace all the occurrence of A in the message. Okay, this is called as the mono-alphabetic ciphers. Mono is single, isn't it? So mono-alphabetic is single key is used. If K is 3, single character is going to change all the occurrences of one character. Okay. Relationship between letters of plain text and ciphertext is always 1 to 1. Okay. 1A will be replaced by 1D. D is not repeated for any other characters. D is replacing only A. Okay. If it is O will be replacing the N. It will not replace any other characters. It is a 1 to 1. O is replacing only the N. D is replacing only the A. So there are S. If it is going to be replaced by U, all the S will be replaced by U only. Or U replaces only the S, not the other characters. U is not used to any other character like L or Y. U is replacing only S, which is called as a 1 to 1 relationship between the characters in the plain text and the ciphertext. Okay. Example here I have given plain text. If it is hello, ciphertext will be KHOR with K equals or key equals 3. Okay. Next is example with plain text hello, where ciphertext will be random. This is also a 1 to 1. That means A is replacing only the H. It will not replace any other characters. Okay. But are randomly replaced. Not in an order. Are randomly replaced. Okay. This is an example of polyalphabetic ciphers where you can have multiple characters for the same letter. See, here example is L are repeated 2 times, but in the ciphertext, first L is replaced by N, whereas second L is replaced by Z. Okay, this is called as the polyalphabetic ciphers. Alright. Next is called as the additive cipher. Okay, additive cipher or shift cipher or is called as the scissor cipher. Okay. What is the concept behind the additive cipher is each character is assigned a unique integer value to the selected key value and performed modulo operation. That means replacing it by the alphabets or adding the values to get a new character. Okay, each character is assigned a unique integer. So if you have 26 alphabets, okay, it will be replaced by an integer value like in this table. This is the plain text. If the small letter alphabets are plain text and these are the ciphertext, this will have an integer value 0, 0 to 25. Okay, since total 26 alphabets are there in English, the integer value is given from 0, 0 to 25. Okay, this concept usually is used in all the almost kinds of ciphers. Okay, modulo operation, mod operation will be done with the value 26 because the number of alphabets in English are 26. So, usually modulo operation will be done by the number 26, which is represented as Z26. Okay. The general expression in an additive cipher is using the plus symbol, that is addition symbol. Okay. P is the plain text and C is the cipher text. How do you are going to generate the cipher text is by adding a key value to the plain text and getting a modulo operation by 26. Why do we do modulo operation from 26 is English alphabets have English language has 26 alphabets. We assume that message will usually be in English. So, we perform the modulo operation by 26 while generating the cipher text. As I have said in the previous session, encryption will be or decryption will be reverse of the encryption. This is an encryption method. This is an encryption method, whereas this is a decryption method where plain text will be generated by using the cipher text. How do you generate the cipher text is, like I said, decryption is the inverse of encryption. The key value will be subtracted from the cipher text. Okay, C minus K, again you have to make the modulo division by 26 to get the plain text. So, for encryption, additive cipher will have C equals P plus K mod 26, whereas decryption will be P equals C minus K mod 26. Okay. Encryption algorithm adds the key to the plain text and decryption subtracts the key from the cipher text. It subtracts the value. Okay. C equals P plus K by mod 26 divided by mod 26. Decryption is P equals C minus K mod 26. Here we have an example where key is 15 and plain text characters are hello, H-E-L-L-O. Okay, this will be encrypted as WTAAD. How it is generated? H value is 7, E value is 4, L value is 11 and O value is 14. Okay, so 7, 4, 11, 14. Okay, these are the integer value for the alphabets in the plain text. So, we have to execute the encryption method here. You have to add plain text value, that is value of the H 07 plus 15 will give you 22. 22 mod 26, mod operation you know, getting the remainder, is it not? Modulus is getting the remainder, is it not? 22 mod 26 will give the remainder 22, is it not? So, the integer value 22 represents the alphabet W, is it not? We'll get the value 22 which represents W. Next is E, 4 plus 15 will be 19, mod 26 will give the plain text E has the value 4, 4 plus 15 is 19 mod 26 will give the number 19. 19 represents the cipher text alphabet T. Okay. Like this, 11 plus 15 will give you 26 mod 26 will be 00, which gives the alphabet A, repeated for another L. Now, 14 plus 15 will be 29 mod 26 will give you the value 03, which is a D. Okay, it will be encrypted as WTAAD. This is the decryption one. Now, I take 22 minus 15. Okay, the key is 15. C minus K, 22 minus 15 will give you 7 mod 26 will give you H. Okay, 19 minus 15 will give you 4 Mod 26 again will give you 4, which is the character E. Is it not? Next, A00 minus 15 will give you 15 mod 1100 minus 15 will give you the value 11, which is L. Then decryption, same L. 3 minus 15 will give the modulo 26 will give the value 14, which is the integer value for O. So it will decrypt to HELLO, which is the plain text. This is the cipher text and this is the plain text. This is the plain text. This is how a simple additive cipher will work. Okay. In the next session, I'm going to explain about the other types of symmetric key ciphers. Okay. Thank you.